Have you ever wondered what the universe is made of? This question sends us on a journey into the invisible. Beyond what our eyes can see, beyond the stars, galaxies, and all visible matter, there lies a vast amount of unseen stuff. This unseen stuff, known as dark matter and dark energy, accounts for a whopping 95% of the universe. Dark matter, despite its ghostly nature, exerts a gravitational pull on galaxies, binding them together. It's like the cosmic glue holding everything in place. Then there's dark energy, the mysterious force driving the accelerating expansion of the universe. It's as if the universe is on a never-ending growth spurt. Scientists investigate these elusive entities not by seeing them directly, but by studying their gravitational effects on the visible universe. It's a cosmic game of hide-and-seek on an intergalactic scale. So, while we can't see dark matter and dark energy, their presence is felt throughout the cosmos. What if I told you there are objects in the universe so dense, even light cannot escape their grasp? Welcome to the captivating world of black holes. These celestial phenomena are formed from the remnants of massive stars that collapse under their own gravity after exhausting their nuclear fuel. The result? A point in space with such immense gravitational pull that nothing, not even light, can escape from it. Now let's dive into the event horizon, the boundary around a black hole beyond which nothing can return. It's like the ultimate point of no return. Near this horizon, time slows down, a phenomenon predicted by Einstein's theory of relativity. But wait, there's more. Black holes also generate waves, gravitational waves to be precise. These are ripples in the fabric of space-time caused by the most violent and energetic processes in the universe. Black holes, a testament to the strange and fascinating corners of our universe. Could there be another you in another universe living a completely different life? A question that has sparked countless debates among scientists and philosophers alike. This is the concept of parallel universes, a cornerstone of the multiverse theory. This theory suggests that our universe is just one of countless universes coexisting side by side, each with its own set of physical laws and realities. Theoretical physicists have proposed several types of parallel universes. Some propose that these universes exist in higher dimensions, invisible to us. Others suggest that they are right here, but exist in different vibrational frequencies. The concept of parallel universes even extends to quantum mechanics, where every decision creates a new universe. Scientists are exploring these possibilities, pushing the boundaries of our understanding. Experiments in quantum physics and cosmology are trying to detect signs of these other universes. Even though the evidence remains elusive, the search continues. Parallel universes, a tantalizing prospect that challenges our understanding of reality. What if time is not as constant as we think it is? Imagine a river, flowing steadily in one direction. Now imagine this river as time, its current carrying us from the past, through the present, and into the future. But what if this river could bend, twist, and even loop back on itself? This is the fascinating concept of time in our universe. Renowned physicist Albert Einstein rocked the scientific world when he suggested that time isn't rigid. Instead, it's flexible, bending and warping under the influence of gravity. This idea, part of his groundbreaking theory of relativity, implies that time and space are woven together in a four-dimensional fabric known as space-time. Perhaps even more intriguing is the suggestion that time might be more than just a passive background. It might play an active role in the evolution of the universe, guiding the formation of galaxies, stars, and perhaps even life itself. Can you imagine a single point, smaller than an atom, expanding into the vast universe we know today? This is the essence of the Big Bang Theory, a fundamental concept that seeks to explain the origin of the universe. Around 13.5 billion years ago, an explosion of incomprehensible scale occurred, creating time, space, matter, and energy. This singular event, the Big Bang, marked the beginning of everything we know. In the immediate aftermath, the universe was an incredibly hot, dense sea of particles and energy. As it expanded, it cooled, leading to the formation of atoms, stars, and galaxies. But how do we know this happened? Well, the answer lies in the cosmic microwave background radiation. This radiation, a relic from the early universe, permeates all of space and provides compelling evidence for the Big Bang Theory. The Big Bang, a cosmic event that marks the dawn of time and space. In the vast expanse of the universe, what unknown entities lurk in the darkness? Take black holes, for instance. These cosmic vacuum cleaners are so dense and have such strong gravitational pull that even light can't escape them. They are formed from the remnants of massive stars that have undergone a supernova explosion. But they're not the only enigmatic objects out there. Consider neutron stars, the collapsed cores of large stars. They pack their mass inside a 20-kilometer diameter. They're so dense, a teaspoon of neutron star material would weigh as much as Mount Everest. Then there are magnetars. These are neutron stars with incredibly powerful magnetic fields. A magnetar within 1,000 kilometers could strip the data from all the credit cards on Earth. Scientists are relentlessly working to unravel these cosmic mysteries. With every discovery, we come one step closer to understanding our universe. A cosmic zoo filled with wonders waiting to be discovered. Are we alone in the universe, or is there someone else out there? This question has sparked countless debates, scientific investigations, and a fair share of science fiction tales. But the quest for answers is far from over. In recent years, numerous UFO sightings have been reported, some even by military personnel, leading to a renewed interest in the extraterrestrial. Theories about extraterrestrial life are as varied as the potential forms life could take. From organisms thriving in the most inhospitable environments on Earth, we've learned life's resilience, prompting us to consider life existing in the harsh conditions of outer space. Astrobiology, the study of life in the universe, has made significant strides. We now have the ability to detect biosignatures, the telltale signs of life, on distant planets. The exploration of Mars has also opened new avenues in our search for life beyond Earth. The search for extraterrestrial life, a quest that may redefine our place in the cosmos. At the smallest scales, does the universe still obey our intuitive understanding of reality? Quantum physics answers this question with a resounding no. In the quantum realm, particles can be in multiple places at once, pop in and out of existence, and even affect each other's behavior from light years apart. This sounds more like a science fiction story than a scientific principle, doesn't it? This brings us to one of the fundamental principles of quantum physics, the uncertainty principle. It states that we can never know both the exact position and momentum of a particle at the same time. The more precisely we measure one, the less precisely we can know the other. This isn't due to a lack in our measuring equipment, but a fundamental aspect of nature itself. So, what does this mean for our understanding of the universe? Well, at its most fundamental level, the universe is not deterministic, but rather probabilistic. Quantum physics, an enigma that challenges our grasp of reality. How might we traverse the vast distances of the cosmos? A question that has sparked countless imaginings and scientific inquiries. Theoretical methods of space travel range from the concept of warp drives, bending the fabric of space-time to allow spacecraft to cover vast distances in a snap, to wormholes, a shortcut through space and time. But let's be clear, much of what we know resides in the realm of science fiction, rather than proven science. Warp drives and wormholes are fascinating concepts, yet they remain unproven and largely theoretical. However, this doesn't mean they are impossible. On the contrary, they represent the edge of our understanding, the frontier of human knowledge. As we continue to explore and understand the universe, these concepts may transition from fiction to reality. The reality of space travel could be far stranger and more fascinating than anything we've yet imagined. Space travel, a dream that may shape the future of humanity. What mysteries does the future hold for our understanding of the universe? As we stride forward into the unknown, science continues to uncover new mysteries and paradoxes that challenge our understanding of the cosmos. Consider dark matter and dark energy, unseen forces that hold galaxies together and speed up the universe's expansion. Or black holes, cosmic oddities so dense not even light can escape. Let's not forget about the tantalizing concept of parallel universes, an idea that could redefine our perception of reality. Then there's the intriguing nature of time itself, a dimension we are yet to fully comprehend. The Big Bang Theory continues to evolve, offering deeper insights into the birth of our universe. Unidentified space objects, the search for extraterrestrial life, and the enigmatic principles of quantum physics add more layers to the cosmic conundrum. The possibilities of universe travel linger in the realm of science fiction, yet inch closer to reality with every scientific breakthrough. The universe, a cosmic puzzle with pieces yet to be discovered.